So regarding the methods of charging, so far we have studied about two methods. One of the methods, if you recall, was induction, and another method that we studied was through rubbing of two bodies. So rubbing and induction. Do you think there are any other methods of charging? Let us find out. Now consider this animation. Over here, you will find that in the first case, a number of flies are taken and are kept in this jar. Now the other jar that is kept adjacent to it is absolutely empty. And in between the two jars, there is a divider kept so that the flies cannot cross from this jar to this jar. Now what happens is we take out the divider. Now the moment we take out the divider, the flies redistribute themselves with both of the jars. That is, we can say that initially when the flies were inside this jar only, after we remove the divider, that is, after we remove the partition, the flies redistribute themselves in both the jars. So we can derive this same analogy and apply it for charges. Consider a neutral rod AB that has been kept on an insulating stand. Now over here, a negatively charged rod is brought in and it is touched with the rod AB. Now since the negatively charged rod that has been brought in has an excess of negative charges, these negative charges flow into the conductor AB. Now as you can see, conductor AB is now getting an excess of electrons, whereas earlier it had an equal number of electrons and protons. So now after the negatively charged rod is touched with AB, AB is getting an excess of electrons and it is becoming negatively charged. Now the reason for keeping the conductor AB on an insulated stand is so that it does not touch the ground. As you can see, the conductor AB is getting negatively charged once touched with the rod. Similarly, this neutral conductor AB can be charged positively. We bring a positively charged rod and touch it with conductor AB. So once this positively charged rod is brought in and touched with conductor AB, electrons move from AB into the positively charged rod and AB becomes deficient in electrons. That is, the number of electrons decreases and the number of positive charges left behind becomes more. So as a result, AB becomes positively charged. So this method of charging is known as conduction. Conduction is the phenomenon by which charges are transferred from one object to another through direct contact in between them. As you saw in the previous two cases, the positively charged rod and the negatively charged rod were actually touched with the conductor AB in order to charge it. So this process is known as conduction. So before conduction in the body, we saw that the total number of electrons remained equal to the total number of protons. In other words, the total number of electrons in body 1 remained equal to the total number of protons. Now after conduction had taken place, we found that the total number of electrons did not remain equal to the total number of protons. Why? Because in this case there was an actual transfer of charges taking place. Electrons were either moving from the rod to the conductor if the rod was negatively charged, and electrons were moving from the conductor to the rod if the rod was positively charged. So in this case, the electrons and protons, that is negatively charged and positively charged particles, were not equal in number after the conduction process. So what is the basic difference in between induction and conduction? The very basic difference is that in induction there is no direct contact in between the two bodies. It happens when a positive or a negatively charged rod is brought near the conductor but not touched. However, in conduction there is a direct contact between the two bodies. That is, the negative or the positively charged rod is actually touched with the conductor in order to charge it. Now I have a question for you. Is charging, that is the method of charging, charge separation or charge transfer? And the options are: charging is only charge transfer, charging is only charge separation, charging is neither charge separation nor charge transfer, charging can be both charge separation as well as charge transfer. So what do you think the correct answer is? The correct answer is charging can be both charge separation as well as charge transfer. Recall that in case of induction, a separation of charges took place. The negative charges accumulated at one end and the positive charges accumulated at another end. But in case of conduction, charge transfer took place. That is, the electrons were actually transferred from one body to the other. So charging can be both charge separation as well as charge transfer. Now, a body can be charged by. This question is, in how many ways can a body be charged? Or rather, in what way can a body be charged? And the options are rubbing, induction, conduction, or any of the three. The correct answer is any of the three. Why? Because in our previous discussions, as well as in this discussion, we have learned that we can charge a body by rubbing, as we saw, let's say, in the example of the glass rod and silk cloth. A body can be charged by induction, that is, when we bring a positive rod or a negatively charged rod in front of a neutral body, charge separation was taking place. And we also saw that a body can be charged by conduction by the transfer of electrons in between them. So thus we can say that the correct answer is any of the three, because a body can be charged by any of the three above methods.